Hello Stings. In today's video I will be covering systems of inequalities. We will be working two examples and those will be problems 5 and 7 in this handout. So if you will turn over the page and let's look at problem number 5. In this problem we have the system of equations. X is less than or equal to -3. And then we have 5x plus 3y is greater than or equal to -9. So the first equation is inequality has the x and no y variable in it. So this is a situation where we have a vertical line through x being -3. So we have x is -3. And because of the inequality sign being an equals, that means we're going to have a solid line that goes here through x equals -3. So I'll go ahead and graph this vertical line at x equals -3. And because it's an inequality, we need to shade. So we want values of x that are less than -3. Those values are over here to the left of -3. So just like when we graphed linear inequalities, we graph the line and then we shade accordingly. With systems of inequalities, we are graphing two lines on the same coordinate plane, just like when we solved systems by graphing, except this time we are going to be looking for, instead of where the lines intersect, we are going to look where our shading is intersecting. For the second equation, we have 5x plus 3y is greater than or equal to -9. And so what we will be doing here is solving for y. So underneath, go ahead and take the inequality, solve it for y. First thing, we get rid of the x term, so I'm going to subtract 5x from both sides. And then the next is to divide everything by 3. Since I'm dividing by a positive, the inequality sign stays the same. I'm going to have a slope of -5/3, and 9 divided by 3 is 3, so we have a y-intercept of -3. So I will go to the y-axis. There's my -3. My slope says -5/3, so if I go up 5, I'm going to have to go left 3. 1, 2, 3, 4, 5. 1, 2, 3. So here's the other point. This also is an inequality with equals, so that means this line is going to be a solid line. So let me move the paper here to graph this line. So we have that line graphed, and this time we want things that are above this line. So we want to graph up here. So the area right here at the top, this little V area right here, is where we have both of the inequalities overlapping. So this is our solution area right here. So for example, the point here is in the solution set, so that is -4, 5. So -4, 5 would be a point that is in the solution set for this system of equations. So let's look at problem number 7. We have x plus y is greater than 2 and 2x minus y is greater than 1. So we'll take x plus y is greater than 2. Let's solve that for y. So we're going to subtract x from both sides. So we are going to get a -x plus 2. For the other equation, or excuse me, inequality, 2x minus y is greater than 1. Subtract 2x from both sides. And now we're going to have to divide everything by -1. Let me move this up so you can see better. We're going to divide everything by -1, and because we're dividing by a negative number, the inequality sign is going to shift to its opposite. Negative becomes positive, positive becomes negative. Now both of these inequality symbols are strict inequalities, so we will not be having solid lines, we are going to be having a dashed line. So let's graph y is greater than negative x plus 2. We go to our y-intercept of positive 2. We have a slope of negative 1. So if I go down, I go to the right. And if I go up, I go to the left. So now we've graphed points, and we are going to have a dashed line here. So for me, the easiest thing to do is just put a little dash in the points that I graphed, especially these being close enough together. You can still see that they are connected. So here we have y is greater than negative x plus 2. We've got the line graphed correctly. Now we need values of y that are greater than this line. So those are going to be things on the y-axis that are bigger than 2. So that's going up this direction here. So we'll just shade in this area here. For the next line, we have y is less than 2x minus 1. So our y-intercept is negative 1, and we have a slope of positive 2. So we go up 2 over 1, up 2, right 1. Or we can go down 2 and left 1. This line is also going to be dashed. And then we have to figure out how to shade. We want values of y that are smaller than this line. So basically smaller than negative 1. So that's going to be down in this area. So we want below the line. So now we can see that if we had any of these points out here, for example, this point here, which is the ordered pair 4, 3. So here we have 4, 3. This is in the solution set of this inequality. So where the inequalities overlap, that is your solution set. Thank you for your attention. Have a great day.